Hi everybody. We're going to do a bit of trigonometric functions revision. There's a lot here to do, so I don't know how many takes it's going to take, but I'll give it a good go. Got a bit of a headache, so hopefully I get it the first time. So in this case, we've been given some characteristics of a sine function, and we need to find the equation for it. So the amplitude's 3, the period's 2 pi. Y. For these cases, I'm only going to look at the positive solution, but there is actually a negative solution for each function that also works. So, y equals, the amplitude's 3 sine x. I know it's sine x and not some other coefficient because to convert between b and period, it's just 2 pi divided by this 2 pi here, and that's equal to 1. Might not be so obvious for the first one, but it becomes easier as we keep going through them. So similarly, y equals 2. Let's find out the value for b. Sine 2 pi divided by pi is just 2. 2 sine 2x minus 1 for the vertical shift. Let's check the third one. Y equals 5 cosine. We've got 2 pi on 4 pi, which is just a half. Now we've got a phase shift this time, so we have to remember to change the sign. And then add 3. Not too bad so far. Y equals, the amplitude's 1, so this is just going to be cosine. Pi on 2, we have to be a little bit careful with this one. I'll just turn my pen upside down to erase. So 2 pi divided by pi 2 is equal to 2 pi multiplied by 2 on pi. They'll cancel. You've got 4. Then what have we got next? Pi on 4. So x take pi on 4 plus the vertical shift is 2. So far so good. Now looking at this sine one, y equals 4 sine. Now this time we have 2 pi divided by 4. So that's going to be half pi. X plus pi on 2. This is negative. Take 2. So far so good. Y equals 2 cos, so we've got 2 pi on 2, which is just pi. X take 3 plus 4. Now, tangent's a little bit different, whereas sine and cosine has a period of 2 pi. Tangent only has a period of pi. We don't know the amplitude change or the dilation change, so we're just going to put k in front for now. It's a tangent function. Pi divided by 2 pi is just a half. Brackets pi on, oops, that's not right. Where are we doing? X take pi on 3 plus 2. Y equals k tan. Let's see. Again, we're doing with tan, so period of natural cycle of tan is just pi. Pi divided by 4, that equals to pi on 1 times by 4 on pi, so it's just going to be 4. X plus pi on 2 take 6. Y equals 7 sine, back to 2 pi again because we're doing with sine and cosine. 2 pi divided by 6 is pi on 3. X take 3 plus 1. Y equals 3.5 cos 2 divided by a half is equal to 2 pi on 1 times by 2 on 1, so that's 4 pi. X take 3 on 2 plus 2. Let's check my answers quickly, make sure I haven't made any mistakes. 3x, 2 sine 2x minus 1, 5 cos a half, x take a half plus 3, cos 4, x take pi on 4, plus 2, yep, that's right. 4 sine pi on 2, x plus pi on 2, take 2, you're doing good so far. 2 cos pi, x take 3 pi plus 4, correct. Y equals 10, x divided by 2, take pi on 6, plus 2, 4x plus 2 pi, take 6, 7 sine pi x take 1, yeah, plus 1. Yeah, looks good. For a change, I didn't make too many mistakes. What's going on here? What's going on? 4x, 4 pi x, take 6x on 2. I have something wrong here. 4 pi x, yeah, 12 on 2, 6. That's right. Take 2. Yeah, all's good. Okay, so we pretty much got those right. The only thing I would say is that I didn't copy this correctly, so we can probably fix that up. That should be a minus, and if that's a minus, this will be a minus 2. Okay, problem 1 done. Let's have a look at problem 2. This is just working backwards. The amplitude's 3. Now, how do we get from pi x, from 2 pi to pi? Well, quite obviously we'd divide by 2. So the period here would be 2. The phase shift is 0 and the vertical shift is 4. So what we're going to do in this case for working out the period is just think, well, what number is going to be down here to make this into whatever's over there. So let's have a look. What have we got? We've got 3. We know that the amplitude is going to be 0. The vertical shift is going to be minus 3. There's no phase shift. So what would 3 be? Well, it's normally 3 on 2, 2 on 3, I'm guessing. So 2 pi times 3 on 2, the 2's will cancel. And I'll be left with 3 pi. So that's no good. So it must be 2/3 pi then, or 2 pi on 3. Pi on 3? Yeah. That'll get me back to 3. So let's see how that works. So if I have 2 pi divided by 2 pi on 3, does that equal 3? Let's check. 2 pi on 1 multiplied by 3 on 2 pi. That cancels out with that, just leaves me with the 3 that I need for here. Beautiful. Let's do the next one. Negative 3, phase shift of negative pi, or is it going to be positive pi? It'll be positive pi. Opposite of what happens. Vertical shift is 5. Now we start with 2 pi. We want 4 pi. We want 4. So to get to 4, we're going to want to multiply by pi on 2 pi on 1, isn't it? That's not right. Let's think of a better way of doing this. This method is a bit garbage. So what do we start with? We want to get to, the answer is going to be 4. We know that this is going to be 2 pi. We want to know what value is going to go into, or what the period is. That's what normally goes down there. So we have to rearrange this equation. So 2 pi equals 4x, x equals 2 pi on 4, which is pi on 2. Yep, which is right. That's a much better way of doing it. Okay. So what have we got this time? We've got an amplitude of 4. Uh-oh, hang on. We've fallen for a trap. Let's go back a step. This does not give us the phase shift unless we've factorized it. So let's make sure we factorize it. So 4x minus pi that's not right. 4x minus pi is equal to 4x minus pi on 4. So this is going to be pi on 4, and that's going to be 5. Much better. Okay, let's go back to our period problems. That doesn't sound very good. So we start with 2 pi on x. We want to know what to divide it by to get to whatever value of b we've got. This isn't factorized again, so we better factorize it. So y equals 4 cos x on 2 plus pi on 6 plus 7 equals 4 cos half x plus pi on 3 plus 7. There we go, that's better. All factorized now. So it's going to equal a half. So 2 pi equals x on 2, x equals 4 pi. So that's going to be 4 pi. That's going to be pi on 3. That's going to be 7, and that's going to be 4. Check I haven't made any stupid mistakes. 2 ICD 4 pi. Ooh. What's the silly mistake I've made? I forgot to put the negative sign there because that's positive. Well, that's positive. Okay, that was that one done. Let's keep going. 1 minus 2. Right, so simply... Oh, here's another problem. Amplitudes can't be negative. That's positive 3. Amplitudes can't be negative, so that's just going to be 2. Period. Well, why can't the amplitudes be negative? Because it's always taken from the center of the function going upwards to its highest point. This is just the plus 1 that would usually be on the end, so that's easy enough. Factorize out pi, and we'll get a phase shift of 3. Rewrite our function 2 pi equals pi on x. Quite simply, x is going to be 2. Yep. And as usual, we've forgotten the negative sign, because if that's positive, this has to be negative. Right, so these ones are a little bit different in that the period's now pi, not 2 pi, because we're dealing with tan. So that's going to be 3. We have to factorize out 2 as before, so 3 tan 2x minus 1 is equal to 3 tan 2x take a half. So that's going to be positive a half. That's going to equal 2. So that's going to be half pi then. And the vertical shift doesn't have one. What's this one going to be? So, tan doesn't have an amplitude. It extends off to infinity. What's the period of this going to be? It's just going to be pi. The phase shift is going to be negative pi on 3. And it has no vertical shift. So there we go. Check my answers quickly. 3204, 1 2 pi on 3, 0 negative 3, 3 pi on 2, pi on 4 5, 4 pi negative pi on 3 7, 2 2 negative 3 1, pi on 2 half 0, pi negative pi on 3. Oops. I'm guessing when I did this function, oh, it's that I forgot this bit. Dummy. There we go. Okay, so far so good. Now we want to solve this function. Here's one way of doing it. There's lots of different ways of doing it. We'll start with let y equal 2x. So cos of y equals 1 on root 2. Y equals pi on 4. So far so good. Cosine, according to our cast diagram, or a unit circle. Cosine is positive in the fourth quadrant, so it will, if we've got from here to here is 4 pi on 4, 8 pi on 4 is to here, coming back 1 is 7 pi on 4. Because cos is positive in the fourth quadrant. Let me draw it properly and then maybe it's easier to see. So the first one's easy. That's just that one. The second one we want is that one to there. So if it's from here to here, if it was 180 degrees, it would be 4 pi on 4. If it's 360 degrees all the way round, it would be 8 pi on 4. If we're just coming back 1 pi on 4, that'll be 7 pi on 4. That's where that comes from. Now we're nearly 8 pi now, so if we go another revolution, we're going to be over 2 pi. Now that's all well and good for y, if that was the bound. But we're trying to find where this solution solved for x. So what we need to do now is to convert these back to x again. And this is one of the two ways. We could have changed the bounds, or we could do it this way. I find this way a little bit more intuitive. So we know y equals 2x, so x is going to be half of y. To find half of y, just multiply by half. On a half, I'll just divide by 2. So we're going to have x on 8, 7 pi on 8. That's only going to be one revolution, so we better go around again after all. So far we've only got to about here. We've still got to go all the way around. So the next one will be add 8 pi, which would 8 pi on 4, which will be 9 pi on 4, and 15 pi on 4, which will give us 9 pi on 8 and 15 pi on 8. And I believe those are our 4 solutions. Similarly, for a more complicated example, same process though, y equal 2x take pi on 4. So when is tan of y equal to -1? Well, tan is -1 at -45, I believe. So tan of negative pi on 4 is equal to -1. Well, I suppose we could say it a different way. We know that tan of pi on 4 is equal to 1. Tan of pi on 4 is equal to 1. We could look at 40 degrived 1 root 2. If we're trying to remember why it is. Opposite over adjacent. So, if we know that's 1, when is it -1? We're looking at our cast diagram from before. We know that tan's negative in the second quadrant and the fourth quadrant. That would be in when y is equal to pi, oh, we want negative, don't we, not positive. It's negative over there, so that's going to be 3 pi on 4 and 7 pi on 4. Given this is 2x, we're probably going to have to go around a few times. Now the negative sign here indicates it's shifting it to the right, so we should probably go back one solution as well just to check if it's within the bounds. So if we wanted this solution here as well, that would be negative pi on 4. And also go around another revolution, so that'd be plus 8 pi on 4, which would be 11 pi on 4 and 15 pi on 4. Okay, now we can apply this transformation. Let's see what's going to happen here. So you're going to end up with y take pi on 4, y plus pi on 4 divided by 2. Okay, now given that this includes 0, if I add pi on 4 to this, I'm going to get 0 divided by 2 is 0, so that's going to be one of the solutions. I'm quite glad I added that one in. Then the next one, that'd be 8 pi on 4, which is 2 divided by 2. 3 pi on 4 plus another 4 pi is 4 pi on 4, which is pi. And pi divided by 2. 7 says 8 pi on 4, which is 2 divided by 2. 7 pi on 4, 8 pi on 4, 2 pi on 2 is pi. 11 pi, 12 pi divided by 4 is 3 on 2 pi, or 3 pi on 2. 15 would be 16 pi on 4, which is 2 pi. And there we go. I believe those are our 5 solutions. Just check. Pi on 8, 7 pi on 8, 9 pi on 8, 15 pi on 8. Yep, that's correct. 0 pi on 2 pi, 3 pi on 2, 2 pi. Yeah, correct. Well done. Yay me. This one looks a bit more messy. Determine the functions, the constants a, b, c, d, e, and f, and write the equations for f, g, and h. Yuck. Well, let's do this one first. That's a sine function, and here is a sine function. That sine function has an amplitude of 2, so we instantly know that that is going to be 2. We know c now. C equals 2. Now, normally we'd be going 2 pi for a full cycle, but we're only going pi, so we know that d is going to be 2 as well. 2 pi divided by pi equals 2 gives us our in this case d value, so we know that one. So we can write the function now for g. G of x equals 2 sine 2x. First one done. Okay, now what else do we know? Let's see if we can figure out which one's which now. So we have this function, we have this function. Are they the only two functions? Oh, we've got this great big looping curvy thing. So we should probably find out where the top of it is. See if we can find out. That starts there. It'll end over here somewhere. This function here, if we note, it hasn't got a dilation in it. It's only really got a shift. Again, where's the middle of the function? Yeah, it is still, it hasn't been vertically shifted as indicated by something not being at the end. So I'd say again the amplitude is going to be 2. If it's a cosine curve, it's been shifted to the left. So it's going to be a positive shift of 2 pi on 3. So we now know h of x and 2, where have I put that 2? That 2 is in the wrong spot, isn't it? 2 goes here. 2 cos x plus 2 pi on 3. So what do we know so far? We know c equals 2, d equals 2, e equals 2, and f equals 2 pi on 3, which really only leaves our tan function. So if we look here, that's been shifted. Now, the interesting thing about the way they've written it, tan of a x plus b on a. So we're going to have to be a little bit careful. Normally, we'd expect at 45 degrees for it to be 1. Has it got a vertical shift? It has, hasn't it? So here's the middle, and here's there. The question is, how far has it gone? So from here to here, pi on 6 is 30 degrees, so that's 60 degrees from there to there. And we've got 1, 2, 3, 4. So each one of these is 15 degrees, 15, 30, 45 degrees. So it's gone 45 degrees up 1, so that's telling us that E is actually 1, not E. A is 1, which makes it nice and easy, because then B is just going to be what we think it is, which will be 2 pi on 3. I'll check my answer quickly. Question 7. Where are we? Here. No? 7. Here. A is 1, that's good. B is pi on 6. Oh. Well, let's check that. Yes, B is pi on 6. I'm an idiot. It's only been shifted from here to here, which is pi on 6. 7. C is 2, D is 2, E is negative 2. Well, let's have us a look here. E so I think this comes down to the case that you can have multiple solutions for this. Where x is in radians, it doesn't tell us. Yeah, okay. I don't think my answer's wrong. All they've done is they've said that the function is upside down at this point. Turn it upside down, shift it that way. I just shifted it the other way. So it doesn't say I can't have a negative solution. So what's this going to be? This is... Oh, I can put in here what they've said. They've said the function's upside down at that point. That would be negative 2. And it's been shifted positive pi on 3. I don't disagree, it's just a different way of saying the same thing. So in that case, that's going to be E and F. So that's for this function here, it's the cosine function, so I'll rewrite it. Negative 2 cos x take pi on 3. And f of x. F of x will equal to tan of x plus pi on 6. Now is it really plus? No, it's minus. Okay, now if we wanted to find out when f of x equals h of x, we'd have to identify which graph's which. So f of x is the tan function, that's this one here, and h of x is the cosine function, which is this one, and we want to know when they're equal. Well, there's a point here where they're equal. There's another point over here where they're equal, and there's a point over here where they're equal, and another point over here where they're equal. So from negative pi to pi, it'll be negative 5 pi on 6, negative pi on 6, pi on 2, and 5 pi on 6. Am I right? Yep. Excellent. Solved. In that interval, state the values of x for which the function f is increasing. So the function f is the tan curve. The only time the function is not increasing is at negative 2 pi on 3 and negative pi on 3. The asymptotes, because it's increasing and still increasing. Oh, you can see the graph is decreasing here and increasing there, I suppose. Let's check the answers and see what they mean. Like, because if I'm looking at this function, it's got positive gradient everywhere, so you could say that it's increasing all the way. But if they mean that it's the gradient of the curve is at a decreasing rate, no, I think the only 2 points it's not increasing is at those two values. And function g is decreasing. Right, so where's function g? That's the sine curve, which is this function here. Well, would you say it's decreasing between there and there? And again, between here and here. So then I'm going to address that one right now. Might be one for me to have a bigger think about. So, amplitude of the graph. From 7 up to 12 would be 5. The graph repeats here, so that would be 16. Yep, 16. Write two equations that will result in the graph there. Okay. So again, we have to think 2 pi on x equals 16, x equals 2 pi divided by 16, which gives you pi on 8. So y could equal, what's the amplitude that I said? 5. 5 sine pi on 8x. There's one function. Now we could also say that the function's been shifted. It's a cosine function that's been shifted for that way. So we could say y equals 5 cos pi on 8 x take 4. Oh, we forgot the vertical shift. It's been moved up 7. Something like that. Shall we check the answers? Question 8. Where's question 8 gone? There it is. 5 sine pi on 8 x plus 7 agrees with me. Y equals 5 cos pi on 8x take, yep, both of those work. Well done me. Find the exact value of cos 15. Well, I won't do this one in full, but I will show you the method. So we can find cos 15 by finding cos 45 take 30, and we can expand that by using the cos a plus b expansion, whatever that is. But we'll come unstuck. Oh, I suppose I better go find out what it is. Give me a sec. Sine A cos B. Oh, cos I want. Cos A plus B. Cos A cos B. Take sine A sine B. Okay. So that'd be cos 45 cos 30 plus sine 45 sine 30. Right. Now once we have that, the reason I said 45 take 30 is 45 take 30 gives me 15. I can find out all of these. Oh, I probably know them. Let's check. 1 on root 2. Cos 30, adjacent over hypotenuse, root 3 on 2. Sine 45. Sine 30 is a half. Root 3 on 2 root 2 plus 1 on 2 root 2, which is equal to root 3 plus 1 on 2 root 2 multiplied by root 2 on root 2 to rationalize the denominator. It's equal to root 6 plus root 2 on 4. And we can't really simplify much further than that. And it's the same process for these, except this is 45 plus 30. This will be 60 plus 45. And this identity is much more complicated and a bit of a mess. Given that cos A equals 7 on 25 and sine B equals 21 on 29, determine the exact value of cos A plus B. This is the same process. You'll have cos A plus B is equal to cos A cos B take sine A sine B. Now we already have sine B and we have cos A, so we'll need to find cos B and sine A. So let's write down what we know. Cos adjacent over hypotenuse. We'd use Pythagoras to find x, and the same for B. Let's see, that would be opposite and hypotenuse, and find x. That'll give us the missing values. So if we do adjacent over hypotenuse, that'll be cos B, and we discover that for here, and the same for sine B. And I think, and then solve it. I don't think I'll do that here because this has gone on forever as it is. So I hope that was helpful, and I wish you well on your test. Thank you, everyone.